Hi, and welcome to a PSL Demo Day. I'm Jason DeBacker of PSL Foundation in the University of South Carolina. Today, I want to talk about TensorFlow.js, a way to serve TensorFlow through a web page via JavaScript. What I want to do is illustrate a specific application I've been working on. I think it has broad applicability and might be helpful to you. So what I wanted to do, or the trouble we were having, was we have a model that's computationally intensive to solve. And we want to produce a dynamic visualization where users can adjust a number of the parameter inputs to the model. So think of a web visualization where there are slider bars for a number of different parameters, and we want to update the model results for each of those parameterizations that are some combination of the sliders the users choose on this web page. Now, again, we can't have that model being computed in real time because it's very costly. We also, we can't cache so many results, right? If we have 6 different parameters and we want, 10 values for each of those, now you're talking about millions of runs of this computationally intensive model. So what we want to do is we want to figure out a way where we could have a limited number of model runs and produce an interpolation between the different parameterizations. Now you could do linear interpolation or a cubic spline interpolation. These things have become kind of complex in high dimensions, though. So what we thought to do is let's make a surrogate model that is not just interpolation, but we'll base the surrogate model on a machine learning model. In particular, we're going to use a neural net. And we can train that neural net in Python via like a TensorFlow package, for example. Then what we want to do is we want to have the output of that neural net available on the web. Now, fortunately, there's a project called TensorFlow.js that integrates TensorFlow with JavaScript, which can then help you serve your TensorFlow model on a web page, right? So we've set up a little prototype web page to show how this can work in principle. The hope is to hand that off to experts at making web visualizations who can take it the last 10% of the way and make something pretty with it. But here I want to share just the basics of how do we get from that surrogate model to the TensorFlow.js model that's served on a web page, okay? This took me some time to figure out because there's some version incompatibility. So kind of highlight here where you need to be careful in this process, okay? So let me share some of my code. I'm going to start with a notebook that trains the surrogate model. So in this notebook, we're using kind of standard Python libraries, as well as TensorFlow. So we got imports here of NumPy, Pandas, and TensorFlow, as well as scikit-learn, just to use a nice functionality to split our data between test and training data. After importing those packages, the first thing we're going to do is we're just going to take our data and kind of split the X and Y variables out into 2 different data frames. So we'll do that next. This is just an example data set, but it's based on the structure of what our model produces. So we've got in this example data set, we've got 7 different parameters that are going to vary. And we've got 2 output variables that are produced from combinations of those and other parameters via the economic model. All right, so we split our X and Y. We'll use 70% of those data to train the model, 30% for our validation. And then the next 2 cells here that I'm executing now are setting up the structure of this neural net. So we're going to basically have an input layer that's going to take those 7 parameters. And then we're going to have a neural net that is 2 layers deep with 70 nodes in each of those layers. And then the output layer is going to return those 2 outputs of the model that we're interested in. All right, and we're going to use ReLU activation functions here, just a nice form when you're doing these deep nets here, and in particular for our output here, which is a continuous value. I'm going to set up a loss function next. We'll just use a mean squared error, and then we'll use the fit method with our TensorFlow model to train the model, okay? So I said this is 200 epochs. I played around with this a little bit just to make sure the model fit is there. But the idea here is we just want to fit our a neural net to the output of the model. So we can see how different combinations of inputs map to outputs, right? And eventually what we want to do is, again, use this model on the web as kind of the lookup table, so to speak, for when a user puts inputs onto that web page, what outputs will they see? All right, we're almost there with our training of this model. All right, so we can train it, we can evaluate the model fit, which is pretty good. And then now comes the important part. Once you trained your model here in TensorFlow, is we're going to save the model output. We're going to save it as H5 format, and we're going to use the keras.model.save function so we can save the full model, which is going to have essentially two components. It's going to have the structure of the model and then the weights that are the parameters in that model structure. Okay, so after saving that, the next thing we're going to do is we're going to use the command line here in the notebook with the exclamation. We're going to the command line, and we're going to use the TensorFlow.js converter to read in that TensorFlow model we just saved and convert it to a format for TensorFlow.js, and it's going to save it to a folder called TF model. Let me execute that command. And that's going to save, again, some model results. Let me go to a window there. So let me open up a Finder window. I'll navigate to the directory where these were saved. And for this simple neural net, with just the two layers, we have a pretty small footprint, as you might imagine, to the saved output. There's really just two files there. You're always going to have a JSON file that's going to be saved. And then there may be as well there is also going to be a binary file saved, but there might be multiple of those binary files. Let me just show you my file directory. So it saved all the output to this TF model folder. And you can see here there's two files. One is called model.json. That's telling the structure of this model, how many layers there are, what are the activation functions, and so on. And then there's a .bin or a binary file that has the weights of this model. Okay, and you can see neither of these are very large. We're talking about 26 kilobytes total, so pretty small footprint. And I'll open up in my text editor the model.json file so we can see what that looks like. All right, so let me get a better view here. Word graph. And here's that JSON file called model.json that has, again, what is the format, version, that Keras version that this was generated from, TensorFlow.js converter version, and so on. Okay, that's one of those key inputs that comes out of this. So this notebook has a couple other things just to reload the model and test the predictions. But really, we've done the substantive work here of getting that model from TensorFlow to those TensorFlow.js objects. Okay. Now, the trouble I was having and spun my wheels for a bit on is that the version really matters. So when working with TensorFlow.js, the latest version of TensorFlow that can be used is 2.15. And so here you can see Keras version 2.15. So what one needs to do is make sure that in the environment they're working with, the Conda virtual environment they're working with, that when this model is trained, that they're using TensorFlow 2.15 and no later than that, or else you won't be able to convert the model into the proper TensorFlow.js format. Okay, so that's kind of the key here to doing this. Otherwise, it's straightforward machine learning with TensorFlow, training the neural net, and then we're going to use that TensorFlow.js converter to convert that model to the JSON and binary files that TensorFlow.js is going to work with. Okay, so once we have those TensorFlow.js files, how do we look at those in a web page? Okay, so right here I'm sharing this example script, just a simple web page, just a little bit of HTML to show how TensorFlow.js can be used here to serve this surrogate model based on a neural net trained in TensorFlow. Okay, key thing at the beginning is we need to bring in the TensorFlow.js script. So that's the first line here in the HTML is to get the TensorFlow.js loaded into this web page. Now, this website is really simple. Let me share what this looks like. See how it previews here in VS Code. So the web page is essentially just take or have an input box that takes a value of number of years you're shifting a parameter by. And then there's a calculate button. Once you hit that calculate button, then the NPV, the result, is going to be calculated and returned in that output cell. Okay. All right. So with that in mind, you can see that our HTML code in the body is just the code to create the box that takes the input called input M here, and then a button called calculate that once it's clicked, you call this do surrogate function. The do surrogate function is the one that loads the model, the TensorFlow model coming from that model.json file. It's going to take the element from the input box, pass that to the input tensor for the TensorFlow model, and then get a prediction based on that input. And that prediction will then be put in the output box that is created in the body above. Okay, so kind of as simple as that. Let me stop sharing this, and what I'll go to is an example, or just the working example here. So I've got this opened in Google Chrome and served with Docker locally. And we can put values into that input box, say 3. We can calculate the outputs. Okay, so we can get inference, from that neural net to get predictions for any kind of number of shifts, even if we didn't solve the model for that particular parameterization. Okay, and again, this is just kind of very simple working example of how to make this surrogate model available on a web page, how it can be used to predict outputs given a set of inputs. And in the future, look for this to be a much prettier working example with a visualization and multiple parameters being adjusted. But again, the foundation is all here because we've got the surrogate model available to that web page, and we can put as many inputs as we want up to the number we have in our surrogate model and see all different combinations of those inputs and the outputs that correspond to them as predicted by the neural net. All right, so I hope this is helpful to you. I'll follow up this demo day with a blog post at pslmodels.org so you can read more about it, and where I'll put links to the repository where I'll share all of these Python and HTML scripts to reproduce what I've done here. All right, thanks for tuning in today. Have a good one. We'll see you at the next demo day. Bye.